Hello friends, welcome to VK Lectures. In this lecture we are going to discuss the first 5 questions from the question paper, physics question paper of Karnataka SET 2020. Now this is our first question. Now the question is to identify the vector that is perpendicular to both I plus 2j minus 3k and minus I plus minus I plus j minus 2k. Now let us consider this vector as A and this as B. Okay. Now we have to identify a vector C such that A dot C and B dot C both are equal to 0. Now that means our aim is to find out the vector C. Now here we have the 4 options given. Okay, now let us do one by one. Here we can write I times I, that is 1, plus here you have 2j, 3j, that is 6, minus 3 times 2, that is minus 6. That means which is not equal to 0, right? Now here again we have I times 2i. You can put I times 2i, which is nothing but 2, plus 2 times 3, that is 6, minus 3 times 1 is minus 3, again which is not equal to 0. Now you have the third option, I times I, that is minus 1, 2j times 5j, that is 10, again minus 3 times plus 3, that is minus 9, so minus that is equal to 0. Now you have the fourth option, I times I, that is equal to 1, 2j times j, that is plus 2, minus 3 times 1, that is minus 3, so here is also 0. So your required answer should be either this one, this vector, that is minus I plus 5j plus 3k, or I plus j plus k. Now here again we have the vector B. Now what we have to do is use this vector B, that is vector B minus I plus j minus 2k. Now take the vector C that we have got from the option C, that is minus what was the vector, minus I plus 5j plus 3k. Okay, now just put the dot product. What you will get is minus I times I, that is 1, plus j times 5, that is 5, 2 times minus 3, that is minus 6. So this is 5 plus that's equal to 0. So the required answer is minus I plus 5j plus 3k. And just for confirmation, let us check with the last option, that is I plus j plus k. Now what we will do is we will use our vector C, that is I plus j plus k dot product with the vector B. What is vector B? Here minus I plus j minus 2k. So what is the dot product giving you? I times, that is minus 1 plus 1, and here you have minus 2, which is not equal to 0. So your option is option C, and the value of C is equal to vector C is equal to minus I plus 5j plus 3k. So this is the required answer. Here the same question we can discuss in another way, that the previous method that we used was trial and error method. Now here we have a direct method called, there is a direct method where we can simply write the vector C is equal to xi plus yj plus zk. This is any arbitrary vector. Then we have two vectors. One is A is equal to I plus 2j minus 3k, right? So here we can write A dot C should be equal to, A is 1, so R1, that is x, plus here you have 2j, here y, that is x plus 2y, and minus 3 times z, that is 3z. Now that is from A dot C. Now we can write B dot C, which is B is this vector, right? So now B dot C is given by, now what is A dot C? A dot C should be equal to 0 because they both are perpendicular. Now B dot C you can write it as minus I times x, that is minus x, and j times y, that is y, that is plus y, and minus 2 times z, that is minus 2z. So that should be equal to 0. Now you have two equations. This is equation 1 and this is equation 2, and these two equations you can just add 1 and 2. What you are getting? You are getting 3y minus 5z equal to 0. Now take each option and check the coefficient of y and z and put it equal to this. For example, now we will check with the option A. What is option A? A is I plus 3j plus 2k, right? Here this is the 3 times y. What is y? Y is 3. 3 times y is nothing but 9, minus 5 times z is nothing but 2. 5 times z is 2. So 9 minus 10 is not equal to 0. Now we have already found out. Now check this option C. What you will get is 3 times, what is y? 5, right? 3 times 5 minus 5 times z. What is z here? 3, equal to what? 3, 5, 15 minus 15, which is equal to 0. And you can also check here 2 times, here you have 3y minus 5z. Here 3y, y 3, right? Yeah. So 3 times y is nothing but 3 into 3 minus 5 into 1, which is not equal to 0. Now the last option, 3 into j, that is y is 1 minus 5 into 1, which is also not equal to 0. So only option that you are getting is here, right? So option C. The second question, if vector A is equal to 2yi minus x square yj and phi, this is scalar, 2x square y, then what is a bar dot del phi at 1 comma 1. Now just let us find out what is del phi. Okay. Del phi is equal to I cap into dou by dou x of phi plus j cap into dou by dou y of phi plus k cap times dou by dou z of phi. Now that can be written as I times dou by dou x of phi. This is our phi, 2x square y. There is nothing but 4xy plus j times dou by dou y of phi, that is 2x square. Now what is del phi at 1 comma 1? Just put the value of x and y equal to 1 and 1. So what you will get is 4i cap plus 2j cap. Right. Now what you want? Now we want is vector A at 1 comma 1, which is nothing but 2yi minus x square y j. Right. Now at 1 comma 1 what happens? Y equal to 1, so 2i cap minus 1 j cap, both are 1, so j cap. Now you want the dot product of what and what? You want a bar dot del phi. So that's equal to, take the both vectors, 2i cap minus j cap dot 4i plus 2j. So that is 8 minus 2, which is nothing but 6. Now your option is C. Coming to the third question, the value of the integral from minus infinity to plus infinity d by dx of delta of x into e to the power ikx dx. Now this is nothing but the Dirac delta function and k is constant. Now the question is the integral of this function. Now before going into the question, let us define few properties of Dirac delta function, that is integral from minus infinity to plus infinity delta of x dx is equal to 1. Now this is nothing but step function. Okay. Now here we can also write the d by dx of this particular step function will be equal to delta of x, right, which is nothing but Dirac delta function. Now few more properties are integral a to b f of x into delta of x minus c is equal to, now there are two values for this, if this c lies between a and b, then the value is f of c. That means a less than or equal to c less than or equal to b. Okay, and the value will be equal to 0 otherwise. Okay, otherwise this value will be equal to 0. Now this is the point number 1. Here you have point number 2. The third point is delta of minus x is equal to delta of x. Now what is this meaning? It means that this Dirac delta function, delta of x, is an even function, right? Now the fourth point is delta of a times x is equal to 1 by mod a into delta of x. Fifth point is delta of x square minus a square is equal to 1 by 2 times mod a into delta of, here you have, into delta of x plus a plus delta of x minus a. Okay. Yeah. Now the sixth point is integral f of x into delta n of x dx. Now what is this? Delta n of x is nothing but nth derivative of the function delta, okay, is equal to minus 1 times integral first derivative of the function f into delta of n minus 1 times x, which means n minus 1th derivative of the delta, okay, into dx. Okay, now coming to our question. The question is integral minus infinity to plus infinity d by dx of delta of x into e to the power I kx dx. Now this is the function. Here this is the first derivative of delta of x. Now you can write the sixth point what we have discussed here as integral minus infinity to plus infinity e to the power I kx, that is the function that we have, into delta dash of x, right, dx. So that is equal to minus 1 times integral first derivative of the function, that is e to the power I kx into ik, because the derivative of ikx, times the n minus 1th derivative, which means here n is equal to 1, n minus 1 means 1 minus 1 0, so delta of x. Now bring this ik outside. So what we have, it is minus 1 times ik integral delta of x into e to the power ikx dx. Now this is x. Now go back to our second this thing, that is second point. Here we have written second point, that is integral a to b f of x into delta of x minus c equal to f of c. Now this is from minus infinity to plus infinity, and what is here? Delta of x. So delta of x we can write it as delta of x minus 0 into e to the power ikx, right? So put x equal to 0 here, you get what is f of c, function of c. So e to the power x equal to 0. So that is nothing but 1. So minus 1 into ik into 1, that is nothing but minus ik. Question number 4. Two independent solutions of the following differential equation. So this is the differential equation given. So this we can write it as d square plus 3d plus 2 equal to 0 times y. And then what is d? D is nothing but d by dx. And what is d square? D is d square divided by dx square, second derivative. Now this is equation in two variable. We can split the middle term and write d plus 1 into d plus 2 times y equal to 0, right? So what is the value of d? D equal to minus 1 and d equal to minus 2. So then what is y? Solution is nothing but e power m1x and e power m2x. What are m1 and m2? m1 and m2 are the solutions. So you can write m1 is minus 1, so e power minus x and e power minus 2x. So option A. The number of independent components of real anti-symmetric tensor of rank 2 in 4 dimensions. So you know this is a 4 by 4 matrix. Okay, so it is an anti-symmetric tensor. Anti-symmetric means your diagonal elements, all diagonal elements will be equal to 0. So all diagonal elements are 0. So what is the question? The question is about independent component or independent elements. You can write independent elements in this 4 by 4 matrix. For anti-symmetric, number of independent element is nothing but n into n minus 1 divided by 2, where n is the order of the matrix, where n is nothing but order of the matrix. So what is the order here? 4. 4 into 3 divided by 2, that is 2 into 3, that is 6. So now suppose this was a, instead of anti-symmetric, symmetric matrix. If it was symmetric matrix, then n into n plus 1 divided by 2. And what do you mean by anti-symmetric? Anti-symmetric means A transpose must be equal to minus A. A transpose equal to minus A. Symmetric means A transpose should be equal to A. So for symmetric matrix, it is n into n plus 1 by 2. For example, if it was this question in terms of symmetric, so 4 into 5 by 2. So then that is nothing but 10. Okay. Now, how many elements are there? 16 elements are there in a 4 by 4 matrix. Out of the 16 elements, 10 are independent. So that's for today's lecture. Please note, we are also providing, VK Lectures is providing online tuitions to physics and mathematics students of 9th, 10th, 11th and 12th standard, and also for BSc and MSc students on physics. We also provide online coaching for physics, that is IIT JAM, CSIR NET, GATE, TIFR, JEST, IIT JEE and SET, all state eligibility test like Kset, Karnataka SET, Tamil Nadu TN SET and the Maharashtra SET, Kerala SET, etc. We also provide the problem solving and doubt clearance sections for physics questions for UPSC exams, SSC, AF CAT, ISRO, BARC and DRDO.